Today we are grading Lesson 11 from Module 4 in Eureka from our homework last night. Again, it is perfectly okay if you struggled with this homework last night. It was our first day of applying the distributive property with algebra, so it's okay if you made some mistakes on this homework. What's super important is that you learn from those mistakes, and if you still don't understand what your mistakes are, that you seek out some help and fix those mistakes so that they don't continue to hinder you in understanding the distributive property. So our problem number 1 wanted us to use models to prove that 3 groups of A plus B is equivalent or the same as 3 A's and 3 B's. So I made a little note here to use your models in your math notebook because we glued in these pictures last night or yesterday that I was hoping would show you how to draw the model of the 2 groups of A's and 2 groups of 3's, and then how to do the 2 groups of 5 plus 3. So I was hoping that you would use these models here to help you and understand the 2 different ways to draw it. So what I wanted there was 3 groups of A plus B. So I just drew some shape that was A and B, and then I drew 3 of them because I have 3 groups of A plus B. So A plus B, A plus B, A plus B. Then underneath it, I did it in this order. I didn't add or take any B's or A's away. I just rearranged their order. So instead of having A, I redistributed them. This is why it's called the distributive property. It all depends on how you distribute or pass out these different groups. So here's A all together, and then B. I showed that they were equivalent by showing that they're the same lengths. So again, I wish I would have done this demonstration yesterday, but I got to thinking about this towards one of my later classes and thinking about the distributive property and what that could mean. So let's pretend that I had some friends that helped me out today. So let's pretend I had 5 cute little bears. Well, come in here, little bears. So I have these 5 cute little bears. One way I could distribute or have these bears grouped is all together. So I could say that I have 5 B's for 5 bears. Then I had these 3. Actually, let's not do 5. Let's do 6 bears and 3 cute little bunnies. So one way, oh, that's rabbits. Let's call them rabbits. And we have an R and a B. So one way I could talk about these is to group all the bears together and say I have 6 bears and plus 3 rabbits. That's one way I could distribute them. The other way that I could distribute them is I could make pins where I share the groups of bears and rabbits together. Or like I gave an example in one of my classes, what if I wanted to make goodie bags for my kid's birthday party, but I wanted everybody to get the same amount so people aren't crying, hey, he got more bears than me, he got more rabbits. So if I wanted to make them the same type of groups, then I need to look for my greatest common factor. So when I look at 6 and 3, the greatest amount of groups that I could make out of those would be 3. So if I were making goodie bags, I could then take the rabbits and I could split them into 3 groups, 1 in each group. And then I could take my bears and split them evenly or distribute them, pass them out evenly between the 3 bags. So now I have 3 goodie bags here. You could look at them like this. I have 3 goodie bags that have 2 bears and 1 rabbit in them. It's still the same amount of bears and rabbits that I started with. I just distributed them or passed them out differently. So the way that I could write this expression would be to say I have 3 groups of 2 bears, 2 B's plus a rabbit. So again, the name distributive comes because that if you distribute papers or you distribute, if you're a Pepsi distributor, your job is to pass out papers or to pass out those things of Pepsi. So one way to distribute or to pass these things out is into equal groups, 2 bears, 1 rabbit. And then how many of those groups do I have? 3 of them. Or I could redistribute them, pass them out differently, and I could have all of my bears together in one group and all my rabbits together in one group, and I could say that I have 6 bears and 3 rabbits. Again, I have the same amount, they're equivalent. I never changed how many bears or how many rabbits I have. I just changed how I distributed them. That is the distributive property. So hopefully back at our homework, this could be like if I had 4 dinosaurs in a box and 12 elephants in a box. Well, what if I wanted to redistribute them so that they were in groups of dinosaurs and elephants, but I wanted those groups to be identical? I could use the greatest common factor of 4, and I could have 4 groups of 1 dinosaur and 3 elephants in each of those groups. If I had 18 xylophones and 30 yo-yos, and here I distribute them or have them in groups all together, but I want to make bags to hand out to party goers, I could make 6 equal bags, and each of the bags would have 3 xylophones and 5 yo-yos in them. Each of these is worth +1, by the way. If I had 21 apples and 28 yams, and I wanted to give the fruit evenly to somebody, and I didn't want to give everybody all apples or all yams, I could make a basket. I could make 7 baskets that had 3 apples and 4 yams in each of them. If I had 24 frogs and 56 giraffes together, I could pair them all together, or I could mix them. I could have 8 identical groups that had 3 frogs and 7 giraffes in each of them. If this isn't making sense, please stop and come over and see me so that we can work through some examples together before you move on to the next lesson. Down here, again, we should be getting pretty good at these. First thing you had to do was circle the terms in the expression. So we have 3x plus 13. If you just circled the 13, that's okay, but it's going to be important in 7th and 8th grade that you recognize that the term is a positive 13 and that this negative goes with this 2. It's a -2. So fix that with your checking pen if you only circled the numbers or the variable here. So there is 1, 2, 3, 4, 5 terms. So if you got 5, go ahead and push plus or give yourself a +1. The coefficients, again, co-workers, co-partners, co-captains, those are things that have to work together. So the things that are working together is this 3, this 7, and then I said, remember, there is one that is inferred. There's one here that we don't write down, but it is still there, and that would be that 1 right there for that 1R. It's okay if you didn't get that 1. If you only got 3 and 7, I'm okay with that, but 3, 7, and 1 is the best answer there, +1. And then the variables, you should be getting these with no problems. Those are anytime you see a letter in your problem. X, Y, and R, +1 if you got all 3 of those. And then underline the constants in the expression. These 2 terms right here are going to be constant. They're never going to change. This is going to be a positive 13, a -2. This term could be 21 if y is 3. It could be 700 if y is 100. This term could change, this term could change, and this term could change. The only thing that's going to remain constant is this term right here, these 2 terms right here. On the back, again, we have to solve parentheses. Inside parentheses, we solve PEMDAS starts over. So you should have done 20. Then you should have solved 4, then square that 4, then subtract. These parentheses should not come off until you get all the way down to here because you haven't solved everything in those parentheses first yet. Then when we get to this point, we got to solve for the exponent. Then we can add to get 20 plus 1. This is a problem that was back from a previous unit where we had talked about greatest common factors, and anytime you see those words identical and greatest, that should lead you to go, oh yeah, I need to find the greatest common factor. So if you circled those 2 keywords, +1, And then you needed to answer it. What is the greatest number of snack bags Serena can make? It was 2 snack bags. If you put a label of 2 snack bags or bags, that's worth a punch today. You can put a star. So we have +1 here, +1 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 possible points today. If you got between 9 and 11, great job. You're on the right track. If you got between 8 and 6, you're progressing. If you got 5 or less, again, I'm not concerned. That's okay, but make sure you understand what your mistakes are. And if you are not sure, come and see me so that we can clarify it. Make sure that your name and number is on your page. If you got all 11 correct, it is worth a punch. And then give your papers to your classroom teacher and begin your classwork.